Welcome back again, Science Warriors. We're here for another flip video. Today we're going to be talking about matter and density. Density is another physical property, like we used physical properties to identify metals, nonmetals, and metalloids. This too is a property that we can use to identify substances. Our EQ for today is going to be what is density and how is it measured and calculated, because this is what we've got to be able to do at the end of our discussions and at the end of this unit when it comes to density. So we're going to start off talking about some key terms. The terms are classify, physical state, properties, matter, mass, and relative density. Start off with classify. Classify just basically means we are going to group things together based on similar traits. Like what you see here, we can group things based on color, and we can do many other ways of classification. Physical state is, of course, what state of matter it's in, solid, liquid, or gas. This comes into play, especially when you're trying to figure out the density of a substance. You have to think about it differently when it's a solid versus liquid versus a gas. So water, of course, is a great example of this. Properties we know pretty well, but these are the appearances of an object, including mass, magnetism, their physical state, relative density, solubility, and the ability to insulate or conduct. So a lot of the things we have actually already looked at. So like in this picture, we can notice different properties of different things throughout. Matter, of course, is that anything that has mass and takes up space. We're going to be using that definition a lot today, especially when it comes to mass and then what it means to take up space. So like an atom, it has mass, and then it also takes up a certain amount of space in the universe. Of course, mass is the amount of matter inside of something. So if we have a ball, how many atoms are within that ball contribute to its mass. So we can use scales to measure this and many other things as well. And then the last of which is relative density. Relative density has to do with whether or not something will sink or float in water based on its density compared to water's density, which is considered to be 1. So anything less than 1 will allow it to float. Anything greater than 1 will cause it to sink down to the bottom. So in this case, a water polo ball floats on top of the water because its density is less than that of the water that surrounds it. So we're going to take a quick transition here, and we'll start actually talking about density itself. So to kind of help out with the understanding of what is density, I want you to think about your suitcase when you pack for a vacation. Usually when you pack it, what do you pack in your suitcase? Think about those things. And it's not too heavy, is it? It should be something you could be able to carry. Well, during your trip, a lot of times you're going to buy things like shirts and souvenirs and stuff to save and give to other people. So when you come back, isn't your suitcase a little bit more difficult to pack? Well, usually, I know for me, it always is. So what is happening here? What have we done to it? Okay, think about it in scientific terms. What has happened to your suitcase's mass? Has it gone up or has it gone down? Well, if we have added more items inside of our suitcase, we have actually increased its total mass. But what about the volume, the amount of space? Volume, again, is how much space something takes up. So the suitcase's volume, has it changed at all or has it stayed the same? Well, it has actually stayed the same. This is why it is harder to pack, because you're now trying to fit more matter inside of a given space. Eventually, all your room will be taken up, and you won't be able to pack any more into it if you buy too many souvenirs. So, let's think about the word dense and density. Other words that you should kind of be thinking about or should come to mind is things like being compact, how concentrated, compressed, packed, how thick, or if something is squashed. These all things can go along with what it means for something to be dense. So, can the density of an object be measured? Well, yes, it can. We have a formula for that, a mathematical formula. That formula is mass divided by volume. So we have to figure out what are these two measurements for an object in order to figure out its density. So let's say that the density of paper is 0.5. Well, what does that number mean exactly? Well, let's take a wooden block and kind of help ourselves get a better understanding. So, if you're to take a cubic centimeter out of a material, its mass would be that number. Well, that statement's going to make a lot more sense in just a moment. So, we have this wooden block. In this wooden block, we know that its total mass is 32 grams. Remember, in science, when we work with numbers, we must have units attached to our numbers or we don't know what we're talking about. Okay, so then what is its volume? If we want to figure out eventually its density to better understand this upper statement, we need to figure out its volume. Well, volume is length times width times height for things that are regularly shaped or cube-shaped type items. So in this case, we have 4 centimeters times 4 centimeters times 4 centimeters. That is having to do with its height, its width, and its length. So we just multiply these three together, and we should get a total of 64. Well, what are our units here? Well, we've multiplied 3 different measurements of centimeters, so we write that as centimeters cubed with a exponent 3 in the end. That is how we write the volume of a regular shaped object, is with the unit that we measured with cubed. Well, then let's figure out its density. Its density is going to be mass divided by volume. So we have the mass, 32 grams. Let's plug that in. We're going to divide that by its volume that we just figured out, which is 64 centimeters cubed. And we're going to get an answer of 0.5. Now the units here get a little crazy, but that's because we took grams and divided them by centimeters. Well, that doesn't give us an actual measurement, so we represent it as grams divided by centimeters cubed, or we say that as grams per centimeter cubed. Okay, so if we take the block and we break it down into cubic centimeter pieces, just like we see here on the screen, and then we only take one of those. Okay, this is our cubic centimeter of wood. Its mass is going to equal the density of the total piece of wood. So, what that's saying, since there is this answer here, 0.5 grams per centimeter cubed. Okay, if we took a single cubic centimeter of that material, its mass is going to be 0.5. That's what the answer in density tells us. Okay, so let's talk about those units just a little bit more. Please excuse the dogs in the background. The metric abbreviations that we use for mass and volume mainly are grams, which is G, and cubic centimeter, which is cm cubed. Or sorry, yes, cubed. Well, for density, we take those, put those together, and we call them grams per cubic centimeter. So what I would like for you to do is, since your notes are on page 27 of your journal, on page 26 of your journal, I would like for you to copy down this data table. So, column 1, or first set of boxes, mass of an empty graduated cylinder. 2, mass of a graduated cylinder and water. 3 is the mass of the water in grams. So put the G. Then we have column 4, which is the volume of the water, which is going to be measured in milliliters. And then finally, column 5 is going to be grams per cubic centimeter for density. So what is going on here is that this is how we can find the density of a liquid. Earlier we saw how to do it for a solid, but this is for liquids. These are a little bit more difficult. So because we're using an instrument to measure out the water, we have to figure out what is the the mass of the water itself. So we have to take an empty graduated cylinder's mass first, and then we got to find out the mass of the graduated cylinder and the water. Well, when we take column 2 and subtract column 1's measurement, we get what's left, which is just the water, which is what we want if we want to find the density of it. All right, so let's assume that this is, well, actually, let's not assume. Assuming is bad. All right, but we get our column 3 answer right here, the mass of the water. Then we have mass. We got to figure out the volume. Well, the volume is done by reading the measurement of the graduated cylinder. I have included in a post on Google Classroom an interactive so that you can practice and get used to all of the intricacies of measuring with a graduated cylinder, as well as a triple beam balance, which is what we will use to measure mass. Well, finally, if we get our mass and our volume, we can divide those two to get our density. So ultimately, we want to use the formula mass divided by volume equals density. Well, that is what this right here is indicating to us. We take those numbers and do this. So this is how you can think through a density problem. If you're using liquids, you'll need to use column 1 and 2. If you're using something that is a solid, you just have to find its mass and its volume and then do the step here. So make sure that you copy all of this on page 26 of your journal. So real quick, to kind of reinforce this idea of density. So if we have a space, okay, which is represented by the big, bold, black box. Let's say that is our classroom, and these are all the students in that room. Would you say that this is very dense or not very dense when it comes to how much space, how many different things are inside of this room compared to the size of the room? I would say it's not very dense because we have all this open space. Well, what if we go to a different room? Our class goes into a room that is a little bit smaller. We notice that the space between most of the red dots has now gotten closer together. If we go to an even smaller room, and then smaller room, and then finally the smallest room possible, there's almost no room to move around. So this would be the most dense our class could become, and it is because we have the same amount of mass inside, but the amount of space that mass can take up has been decreased. Now if we increase the amount of volume for that mass, okay, we get more space. The density actually decreases. So if your mass stays the same, but your volume changes, if your volume gets smaller, you become more dense. If your volume gets larger, you become less dense. So this is just a way to think, because this is how gases work with things like compressed air and like a scuba diver's tank. Those kind of things work off of this principle of density and trying to keep as much of that oxygen that's needed for the person, like a scuba diver, in a small volume so that they could carry it and not have to carry multiples or carry something super huge and heavy that is impossible to take with you. So we're gonna leave you here today. Hopefully this gives you a basic overlook of density. Please make sure that you look at all of the references that were posted on Google Classroom. They are quite helpful, and they can help you work through a lot of the mathematical calculations that we have to do in class. Please be sure that you complete this on time. That way that you are ready to move on when you come back to class on the day it's due. So now that the video is over, please go back to Google Classroom and click on the Google Forms quiz that I have posted there and complete that quiz. This quiz is going to be part of your grade for your notes. So this has 2 grades to it. We have our quiz, and then you have your completion of the notes. So you should have something on page 26 and then your notes on page 27. Alright, Science Warriors, that's going to be it for me today. Hope you guys have a great day, and we'll look forward to seeing you next time, and I'll see you in class. Alright, peace.